Today in Applications of Linear Equations video we will take a look at just one example, and a lot of this fits into what we have already explored this year when we were taking a look at patterns in graphs and things like that. I'll introduce a couple of key vocabulary terms through this example as well. So let's take a look at a little bit of statistics. If we've got a situation in Vancouver where over time we're actually having less and less children in the city, what does that look like as a graph, and how can we model some of that data? So here's some data for you. Over the last little while, so in this column I'll put the year, 1980, 1990, 2000, and the latest survey in 2010, the population of children that are defined as under 18 as a percentage in Vancouver are these numbers. So a column of the percentage of the population who are children. Well, in 1980 it was around 40%, and it's been dropping. So it was 38%, it was 36% in 2000, and in 2010 it was around 34%. So we could go and take this data and we can do lots of things with it. We can find an equation for it and try to model it. We can go and graph it. We can maybe see how this pattern might continue into the future or what that means in the past. So let's just start off by graphing this. And to do that, I'm actually not going to graph this by hand. I'm going to graph this with a little bit of technology. So I'm just going to use Google Docs because that's convenient to use for me. You can do a very similar thing in Excel. And this is switch over to Google Docs and we'll attack this question from there. So in Google Docs, I simply click on Create and choose Spreadsheet, and it'll open up a blank spreadsheet that I can title. I can go into the area here. I can title it, we're just doing graphing right now, title it whatever I want, and now I can go and enter in my data. So I'm going to create a table that looks very similar to what I had, where I have year and I have population of the children in the second column, and I'll fill in my years. There's 1980 and then 1990. And actually, a lot of these programs, Excel and Google Docs, if you highlight two of these cells, it'll detect the pattern. And so if you drag down, I held the key down after grabbing that bottom corner and pull down, it'll actually fill in the other ones for you. So I didn't actually type those in. And then here I had 40%, and then I have 38%, and I'm just continuing to add this data in, 36% and 34%. And then it's quite simple to create a graph from this. Just highlight the data that you want and go to Insert and a Chart. And we want, first of all, make sure that the column A are going to be our labels. And we don't want one of these bar graphs. We want a nice line graph like this. And you can start to see the graph looks like a little bit like what we want. We can go into the Customize menu, and you can change the chart title to something more appropriate. You can go down to the horizontal axes, and that will be the year. And we could go back in time. We could go back to like even 1950, and we can go into the future to like 2050. And we can see what the population looks like. Now, it looks like it's declining a lot, but that's because our scale on the left-hand side is a little bit off. So if you go to the left vertical axis, we can do the same thing. This is the percentage, and we might want to just go from 0 to 100 so that you can see a little bit more. So there's our data, and we've actually joined our data with a straight line, and now we have a bit of a graph. So I can insert that graph, and here it is. You can move it around and see it. You can do things like copy it and paste it in other documents if you want to put it into a Word document or something like that. So let's do that. I'm going to copy this. I'm going to put it back in our notes so that we can use it a little bit more. Okay, so I've pasted the chart into my document here, and so now I've taken that as a table display and I've made it into a graphical display. And what you'll notice is I've got some data that goes from 1980 1980 up to 2010, and I see a pattern in here. Now, if I want to estimate, I know what it is in 1990, but if I just want to estimate off this chart, what do I think it is in, say, 1998 or 1999, then I could try and read off this chart, where does it look like it is over here? So to do that, let's say I'm trying to answer the question, what was the rate in 1998? Well, according to my graph, it looks like if I went to 1998, I'd hit my line here, and if I went across, it would be maybe 35 or 36 or 37. So I'm not even looking back at the data that I had before. I'm just reading directly off the graph that I have now. So I've created a little bit of a pattern here. This line that I have is my pattern. I've created that pattern, and now I'm just using that pattern to try to figure out, if I have that pattern from 1980 to 2010, what might happen in the middle somewhere that I don't have data for. And so in this case, I'm just guessing. It looks like it's going to be maybe 36 or 37%. Now, if I do go check off of here, 1999 is close to, or 1998 is close to here, so it's probably going to be a little closer to 36%. Definitely not 38%, but I can try and read that off the graph. This idea of reading the graph between data that you know, so I know from 1980 all the way up to 2010 I have some data points. Once I have the data graphed and I try to read something in that data set, so from 1980 to 2010, that's called interpolation. Interpolation. And inter means inside. So in this data, if I then go and try to guess a new piece of data that's inside the data that I already know, it's called interpolation. If I try to answer this question, what was the percentage in 1960, or I try to answer the question, what will be the percent in 2040, then I'm using another skill. So I'm going to make a couple of pretty big assumptions here. One assumption is that this pattern of this line continues off into the future, and that exact same pattern happened in the past. I don't know for sure that that happens. I know for sure that that blue line in the middle is true, but I don't know that those red extensions happen. But we'll assume that that's actually true. Well, back in 1960 then, I can try to read that off the graph. So 1960, and then across here, and I try to guess. So 50 is about there, so it looks like it's maybe 46 or 47%. I'm not 100% sure, but it looks like that off the graph. And if I did the same thing for 2040, way off into the future, it looks like it's just a little over 20. So for this one, I might say it's like 21 or 22%. So I'm not building an equation like I did in other sections. And I could do for this. I'm actually trying to read it off of the graph. If I try and do that with some information that isn't in the data that was given me, that was outside of the data. So I was given data again from 1980, between 1980 and 2010. I wasn't given data backwards, and I wasn't given data forwards of 2010. Then if you do this type of guessing down here using your graph, that has a different name. It's called extrapolation, and extra means outside. So interpolation is inside the data set that I was given, and extrapolation is outside of the data set that I was given. Make sure you know the difference between these two terms, extrapolation and interpolation. And we'll practice this in class, doing a little bit of graphing, reading a bunch of graphs, and doing some of this interpolation and extrapolation.